Hi, welcome. In this video, I am going to explain a simple trick to find a particular ligand, whether it belongs to a weak field or strong field. So with this knowledge, it will be easy for you to understand valency bond theory and crystal field splittings. Okay. Before explaining about trick to find weak field and strong field, let me tell you first what is a ligand. Ligand means a single atom or group of atoms. It may be a charged or neutral, which should able to donate a pair of electrons to the metal atom so that it can form a coordinate covalent bond. Coming to this trick here, so weak field ligands means all halogens. Okay, all halogens comes under weak field. What halogens we have? Iodide, bromide, chloride and fluoride, as well as oxygen atom as a donor. So we have few molecules and ions where oxygen atom is acting as a donor. Example, water, oxalate, oxide, nitrito, sulfate. All these particular ligands bind with the metal through oxygen atoms. So here the donor atom is oxygen. That's why they also belongs to weak field ligand. Next, sulfur as a donor atom. There are few ligands where sulfur will bind with the metal through coordination covalent bond. Sulfur will donate pair of electrons to the metal. Example, thiocyanide, sulfide. Okay, as well as we have few ligands with phosphorus as donor atom like trimethylphosphine, triphenylphosphine, etc. So these are all belongs to the weak field. Now coming to the strong field, only two donor atoms. You remember, nitrogen and carbon. If your ligand is having donor atom either nitrogen or carbon, you can say that ligand is a strong field ligand. Example, for nitrogen as a donor atom, you know ammonia. Ammonia is having nitrogen. Here nitrogen acts as a electron pair donor and it binds with the metal through coordination covalent bond. Similarly, En. En means ethylene diamine. See here it acts as a bidentate ligand. Similarly, pyridine. Nitrogen acts as a electron pair donor. In EDT also there are two nitrogen atoms. So EDT is also a strong field ligand. As well as 1,10-phenanthroline. Two nitrogens will be present in this structure. And nitro, NO2 minus, it will bind through nitrogen atom. So these are all having nitrogen as a donor atom. So that's why they are said to be strong field ligands. Next, one more atom you have to remember is carbon. Okay, we have few ligands where carbon is acting as a donor atom. Example, cyanide. Cyanide is a strong field ligand because it is binding through the carbon atom, as well as carbonyl, CO. So it is also binding through carbon atom. So these two also belongs to the strong field complex. Strong field ligand. Just remember that if your ligand is having nitrogen or carbon as a donor atoms, then you can say it's a strong field. And remaining anything, you can say it is a weak field ligand. There is only one exception for that. That is nitride. So even though here nitride binds through nitrogen, it will bind like this with the metal, but it's a weak field ligand. It's a weak field ligand. This is the only exception. So where it belongs to a weak field, even though nitrogen atom as a donor, but it belongs to weak field. So remaining all are very simple to remember. If your ligand is having nitrogen or oxygen as a carbon as a donor atom, you can say it's a strong field. And the remaining anything like halogens or oxygen donor atom or sulfur as a donor atom or phosphorus as a donor atom, you can say that the ligand is a weak field ligand. Hope you guys understand this topic. Thank you for watching. Please subscribe to my channel.